Okay, so what we've got here is for today is basically called the definition of logarithms section. Definition of logarithms. Definition of logarithms goes like this. If I've got log of a base with some argument and it's equal to y, and it can be rewritten as b to the y is equal to x. Alright? And so that's kind of the idea for the definition of logarithms. So we're going to have three skills that we're learning basically today, and that's one is to rewrite logs as exponents and rewrite exponents as logs. That's one skill, both of these things. Then we're going to want to evaluate some logarithms without a calculator. Just mentally evaluate a few logarithms, estimate a few logarithms as well, and then we'll do a word question. Okay, so let's rewrite these logs in exponential form. Remember, the definition of logarithms says that if I've got a logarithm of a particular base and with an argument here and it's equal to something, I can rewrite it as the same base exponent with the output of the logarithm is now the exponent, and the argument of the logarithm is now the solution to this, or the output. Okay, and so then what this means is if I rewrite this using the definition of logarithms, it is 12 squared is equal to 144. Okay, it's that simple. But you really have to make sure that you do it correctly, otherwise you'll be starting off many questions wrong in a way. This is 4 to the 6y is equal to 3x. 4 to the 6y is equal to 3x. And again, just practice it a few times, and you'll be better situated for this. Okay. Then we want to rewrite these exponents as logarithms here. Let's make up, I forgot to write them out. Let's go with 3 to the negative 3 is 1/27th. And then we'll go with the fourth root of 64. It's 2 times 2 is 4, times another 2 is 8, times another 2 is 16. We'll go with a 16, just to make it more simple, is equal to 2. So I'm going to now put in some tricky ones here. So if I want to rewrite this as a logarithm, it's actually pretty simple here. I say that it's log of base 3 of 1/27th is equal to a negative 3. What this implies is that 3 to the negative 3 is 1/27th. Okay. This one here, I'll rewrite it twice, because I'm going to actually write this as 16 to the 1/4. Remembering that radicals are fractional exponents. And so 16 to the 1/4 is equal to 2, the fourth root of 16. And so if I rewrite this using the definition of logarithms, directions here are rewrite exponents as logs, it would be log of base 16 of 2 is 1/4. And what this means is I must raise 16 to the 1/4 power in order to get 2. Okay? And so we're going to take that information with us and go and solve a few more questions where we're evaluating logarithms. Okay? So we'll evaluate the following logarithms without a calculator. We'll do some with a calculator as well, but evaluating them without a calculator is nice. You should be able to look at these and say, all right, evaluate the following logs without a calculator. All right, what I'm going to do is I'm going to actually use the definition of logarithms here, and I'm going to say to myself, 3 to the x is equal to oh wait, I think I messed this one up. This was supposed to be a base 2. There we go. So 2 to the x is 64. What I'm trying to ask ourselves, what is it that what can I raise 2 to in order to achieve 64? So if I just kind of keep one technique, if you're really stuck, I mean, even if you can't, and you're just sort of running out of time, or your mind is sort of like, just keep multiplying 2 together until, 2 times 2 times 2. Try it 3 times. Be like, oh, no, that's 8. Multiply it by another 2. So then keep track of it, though. That was my 4th 2, right? Times another 2. That was my 5th 2. Times another 2. That was my 6th 2. Bang! 6 2s. I needed to do it 6 times. 2 to the 6 is equal to 64. And so log base 2 of 64 is equal to 2. Okay? Even though I actually said evaluate that without a calculator, I should have been doing it over here. 2 times 2 times 2 times 2 times 2 times 2 is 64. My fault. Let's go with another one here. Log of 100. Now remember that if there's no logarithm written, it's automatically a 10 here. So I'm just going to write this 10 in there, as if just to kind of help us out for this first couple of times. And I'll make this equal to some variable, call it r, and then that way when I use the definition of logarithms here, it begins to make more sense. 10 to the r is 100, so therefore r must be 2. So you have to think about, what do I need to raise 10 to in order to reach the value of 100? Okay, now let's estimate a logarithm here. Alright, now what I'm going to say is 2 to what power is equal to 12? Well, there is no exact one, but let's look at 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. And so, therefore, 2 to the 3 is too high. Because remember, I'm trying to reach 12. Right? 12 fits right in there between 8 and 16. So if I'm asking you to estimate one, I would say 2 to the 3 is 8, 2 to the 4 is 16, so therefore, what number do I need to raise 2 to in order to get 12? I don't know, it's somewhere between 3 and 4. So I would say probably that 2 to the 3.5 is maybe 12. And so I would estimate this at 3.5. Right? it's right exactly halfway between. So, I don't know, it's probably more like 3.6 or 7. We can test a few values just to make sure that we know. Alright. So, there we go. 2 to the 3.5 is almost 12. So it's 2 to the... It turns out the ones that are half exact, if 12 is actually exactly halfway between, it usually tends to be a little... The exponent needed to achieve that one actually needs to be a little bit larger. Like I was saying, it probably needs to be 3.6. It's too high even. So it's somewhere around there. Any one of those would be a reasonable estimate. Okay, I'll pause the video now and we'll go for a part 2 in a little while because I have to clear out some hard drive space. But we'll do this one here. Actually, let's see if we can. According to this, I have 2 more minutes. Let's see if we can get this one done. So, a number of visitors to the web page is growing exponentially by the equation t is equal to log n over log 3. T is time in days. T is in days. And n is in visitors. Okay? And so, I would say that how long will it take for 1,000 visitors to see the page? You actually just do log 1,000 divided by log of 3. It's that simple. And so this, we actually, log 10 of 1,000 is actually equal to 3. We can figure that one out mentally. And log 10 of 3, I'm going to actually have to figure out in the calculator by just pressing log and then 3 and then equals, which is 0.477. And then, so if I take 3 divided by log 3, it looks like it's about 6.3 days. Okay. And so these are some simple ones to start out with. We'll do more complex word questions towards the end of the chapter.